This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. Exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
Hello and welcome to this special episode of the ESOcast. Leading up to ESO's 50th anniversary in October 2012, we will showcase 8 special features portraying ESO's first 50 years of exploring the southern sky.
Astronomy is big science. It's a vast universe out there, and the exploration of the cosmos requires huge instruments. This is the 5-meter Hale reflector on Paloma Mountain. When the European Southern Observatory came into being 50 years ago, it was the largest telescope in the world. ESO's very large telescope at Cerro Paranal is the state-of-the-art now. As the most powerful observatory in history, it has revealed the full splendor of the universe in which we live. But astronomers have set their sights on even bigger instruments, and ESO is realizing their dreams. San Pedro de Atacama. Tucked amidst breathtaking scenery and natural wonders, this picturesque town is home to indigenous Atacameños and adventurous backpackers alike. And ESO astronomers and technicians.
Not far from San Pedro, ESO's first dream machine is taking shape. It's called ALMA, the Atacama Large Millimeter Submillimeter Array. ALMA is a joint project of Europe, North America and East Asia. It operates like a giant zoom lens. Close together, the 66 antennas provide a wide-angle view, but spread apart, they reveal much finer detail over a smaller area of sky. At submillimeter wavelengths, ALMA sees the universe in a different light. But what will it reveal?
The birth of the very first galaxies in the universe in the wake of the Big Bang. Cold and dusty clouds of molecular gas, the stellar nurseries where new suns and planets are born. And the chemistry of the cosmos. ALMA will track down organic molecules, the building blocks of life.
Construction of the ALMA antennas is in full swing. 2 giant transporters, called Otto and Lore, take the completed antennas up to the Chajnantor Plateau. At 5,000 meters above sea level, the array provides an unprecedented view of the microwave universe. While ALMA is nearly completed, ESO's next dream machine is still a few years away. See that mountain over there? That's Cerro Amazonas. Not far from Paranal, it will be home to the largest telescope in the history of mankind. Meet the European Extremely Large Telescope, the world's biggest eye on the sky.
Sporting a mirror almost 40 meters across, the EELT simply dwarfs every telescope that preceded it. Almost 800 computer-controlled mirror segments. complex optics to provide the sharpest possible images. A dome as tall as a church steeple. The EELT is an exercise in superlatives. But the real wonder, of course, is in the universe out there. The EELT will reveal planets orbiting other stars. Its spectrographs will sniff the atmosphere of these alien worlds, looking for biosignatures. Further away, the EELT will study individual stars in other galaxies. It's like meeting the inhabitants of neighbouring cities for the first time. Working as a cosmic time machine, the giant telescope lets us look back billions of years to learn how everything began. And it may solve the riddle of the accelerating universe, the mysterious fact that galaxies are pushed away from each other faster and faster.
Astronomy is big science, and it's a science of big mysteries. Is there life beyond Earth? What's the origin of the universe? ESO's new monster telescope will help in our quest to understand. We're not there yet, but it won't take long. So what's next? Well, no one knows, but ESO is ready for the adventure. This is Dr. J, signing off from this special episode of the ESOcast. Join me again next time for another cosmic adventure.
This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. Exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
Hello and welcome to this special episode of the ESOcast. Leading up to ESO's 50th anniversary in October 2012, we will showcase 8 special features portraying ESO's first 50 years of exploring the southern sky. Have you ever wondered about life in the universe? Inhabited planets orbiting distant stars? Well, astronomers have for centuries. After all, with so many galaxies and each with so many stars, how could the Earth be unique? In 1995, Swiss astronomers Michel Mayor and Didier Queloz were the first to discover an exoplanet orbiting a normal star. Since then, planet hunters have found many hundreds of alien worlds, large and small, hot and cold, and in a wide variety of orbits. Now we're on the brink of discovering Earth's twin sisters, and in the future, a planet with life, the holy grail of astrobiologists.
The European Southern Observatory plays an important role in the search for exoplanets. Michel Mayor's team found hundreds of them from Cerro Larrea, ESO's first Chilean foothold. Here's the Corelli spectrograph mounted on the Swiss Leonhard Euler telescope. It measures the tiny wobbles of stars caused by the gravity of orbiting planets. ESO's venerable 3.6-meter telescope is also hunting for exoplanets.
The HARP spectrograph is the most accurate in the world. So far, it's discovered more than 150 planets.
Its biggest trophy, a rich system containing at least 5 and maybe as many as 7 alien worlds.
But there are other ways to find exoplanets. In 2006, the 1.5-meter Danish telescope helped to discover a distant planet that is just 5 times more massive than the Earth.
The trick? Gravitational microlensing. The planet and its parent star passed in front of a brighter star in the background, magnifying its image. And in some cases, you can even capture exoplanets on camera. In 2004, NACO, the adaptive optics camera on the Very Large Telescope, took the first image ever of an exoplanet. The red dot in this image is a giant planet orbiting a brown dwarf star. In 2010, NACO went one step further. This star is 130 light-years away from Earth. It is younger and brighter than the Sun, and 4 planets circle around it in wide orbits. NACO's eagle-eyed vision made it possible to measure the light of planet C, a gas giant 10 times more massive than Jupiter. Despite the glare of the parent star, the feeble light of the planet could be stretched out into a spectrum, revealing details about the atmosphere. Today, many exoplanets are discovered when they transit across their parent stars. If we happen to see the planet's orbit edge on, it will pass in front of its star every cycle. Thus, tiny regular brightness dips in the light of a star betray the existence of an orbiting planet.
The TRAPPIST telescope at Larrea will help search for these elusive transits.
Meanwhile, the Very Large Telescope has studied a transiting planet in exquisite detail. Meet GJ1214b, a super-Earth 2.6 times larger than our home planet. During transits, the planet's atmosphere partly absorbs the light of the parent star. ESO's sensitive 4 spectrograph revealed that GJ1214b might well be a hot and steamy sauna world. Gas giants and sauna worlds are inhospitable to life, but the hunt is not over yet. Soon, the new SPHERE instrument will be installed at the VLT. SPHERE will be able to spot faint planets in the glare of their host stars. In 2016, The espresso spectrograph will arrive at the VLT and greatly surpass the current HARPS instrument. And ESO's extremely large telescope, once completed, may well find evidence for alien biospheres. On Earth, life is abundant. Northern Chile offers its share of condors, vicuñas, vizcachas, and giant cacti.
Even the arid soil of the Atacama Desert teems with hardy microbes.
We've found the building blocks of life in interstellar space. We've learned that planets are abundant. Billions of years ago, comets brought water and organic molecules to Earth. Wouldn't we expect the same thing to happen elsewhere? Or are we alone?
It's the biggest question ever. And the answer is almost within reach. This is Dr. J, signing off from this special episode of the ESOcast. Join me again next time for another cosmic adventure.
On the day of its 50th anniversary, the 5th of October 2012, ESO, the European Southern Observatory, produced a live webcast called A Day in the Life of ESO. This webcast gave viewers a unique opportunity to see inside the world's most productive ground-based astronomical observatory and to help celebrate ESO's first 50 years of exploring the southern sky. Founded in 1962, ESO has evolved into today's preeminent intergovernmental science and technology organization in astronomy, operating 3 unique world-class observing facilities in Chile and its headquarters located in Garching, Germany. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. It's the morning of the 5th of October. The countdown for the webcast A Day in the Life of ESO has begun, and preparations are in full swing. Before long, the live stream hosted by Dr. J, aka Dr. Joe Liske, will begin, giving members of the public the opportunity to interact with ESO astronomers and engineers by listening to live talks and asking questions. Meanwhile, on the other side of the Earth, Brigitte Bael from France, the lucky winner of the Tweet Your Way to the VLT competition, has arrived at Paranal Observatory in Chile and is preparing to claim her prize. a chance to make a live observation using the world's most advanced visible light astronomical observatory, the Very Large Telescope, or VLT. Before long, the first live link from ESO's headquarters in Garching, Germany to Brigitte in Paranal is made, and hundreds of people from around the world watch as Brigitte begins making the observations.
So she is now a full expert and she's going to start the observations. Please. Okay, so now we have sent the command to start the observations.
The target for the VLT is the Thor's Helmet Nebula, an object chosen by public vote as part of the Choose What the VLT Observes competition.
Wow, that's really incredible. This is 30-second exposure time on the VLT. That's what you get. So this is really incredible, and it's really, I did not expect it like that. So what do you think, Brigitte?
It's great.
Back in Germany, Dr. J hosts a series of talks from ESO experts who provide first-hand information and insights into the world of astronomical research.
It's all about questions. We ask questions because we want to know. That's what we do, that's what we live for.
And in particular, what was discovered here was the emission of a simple sugar. And this is important because sugar is at the basic chain that produces energy for life. And this simple sugar was detected for the first time with ALMA.
It's through the high tech that you have an augmented vision of nature. This is where the scientist goes very close to nature. That's the way he can perceive nature.
Before, during and after each talk, hundreds of viewers submit questions to the speakers via Facebook, Twitter, email or the chat box on the live stream itself.
What time of day can you use the ALMA radio telescopes? Only at night?
No, you can use ALMA in principle 24 hours a day.
Mm-hmm. So do you have any advice for those young people out there watching who want to be astronomers?
Yes. My advice is questions, ask questions all the time.
After finding biological activity signs in an exoplanet's atmosphere, what do you think will be the next step? So what will we do next?
I think one of the next steps is perhaps to search for radio signals.
Furthermore, almost 600 viewers from 55 different countries put their ESO knowledge to the test in a quiz that ran throughout the entire day. Between the individual presentations, chapters of ESO's anniversary movie, Europe to the Stars, are shown. This documentary showcases ESO's story with breathtaking visuals. Finally, at the end of the day, a live link to the Paranal Observatory is established once again. Standing on the platform of the VLT Observatory at the 2,600-metre summit of Cerro Paranal, a group of astronomers wait with an anxious Brigitte to witness the results of the observations made earlier. Nobody is disappointed. The VLT has captured a beautiful and spectacular image of the Thor's Helmet Nebula. And with that, it's time for Dr. J to sign off. Marking the end of the live webcast, a day in the life of ESO. For Brigitte, it was a remarkable, once-in-a-lifetime opportunity, and for the viewers, a chance to share her unique experience. What better way to celebrate 50 fantastic years of astronomy at ESO?